Alright, let's talk about VSPER theory and ALEX and talk about some bond angles. And so we'll see questions like this where we'll consider the formaldehyde molecule, and in the last in questions, the central atom, how many lone pairs, what is the ideal angle, and then based upon what we draw in our Lewis dot structures, can we maybe predict differences in bond angles or some deviations in some bond angles. And so let's go ahead and do this Lewis dot structure. And so we have formaldehyde, CH2O. And so let's do our Lewis dot structure the way we always do it. We have 4 valence electrons. In carbon we have 2 valence electrons, 1 for each of the hydrogens, and we have 6 in the oxygen. So we have to account for 12 valence electrons when we draw formaldehyde. And so let's go ahead and do that. And so I'm going to draw my carbon in the middle, my outside atoms here, and then let's go ahead and put in our valence electrons. Okay, so I have an octet right here, and so this looks almost valid. And let's see if we've accounted for all my electrons. I have 2, 4, 6, 8, 10, 12. I do. Notice how I'm violating the octet rule around that carbon. And so for formaldehyde, which I work with quite often actually, then this is going to be the more correct Lewis dot structure. Okay, so here is formaldehyde right here. I have 1, 2, 3 electron groups right there, and so if I look at our notes, then I'm going to see that 3 electron groups gives me a trigonal planar. And if I look at the trigonal planar, when I have the AX3, which we've talked about, then the ideal bond angle here is going to be 120 degrees. And so notice that when I look at something that is bent, for example, we can see that when I have a lone pair up here, or it might be a double bond up here, that it's going to change away from the ideal of 120 degrees bond angle between these 2 external atoms right here. From 120, it's going to make those less than 120 degrees. So let's go back and consider our molecule right here. Okay, so we know that the electron group, that this is trigonal, or no, so trigonal planar, and we know because it is AX3, 1, 2, 3, AX3, that the molecular shape is also trigonal planar. Okay, and then notice that this electron dense double bond there is actually going to change. We were saying this should be 120 degrees. It is actually going to push those in this direction. Okay, so that this bond angle then is going to be less than 120 degrees. And so let's go back and let's look at our ALEX. What is the central atom here? It's going to be carbon. How many lone pairs? We didn't see any lone pairs. What is the ideal angle? Well, we know the ideal angle is 120 degrees from our notes and the table that we have memorized. And so what would we expect the actual angle between the carbon and hydrogen bonds? We would expect those actually now to be smaller because that double bond is changing that ideal angle, in this case, to make them smaller. So when we check those out, it does tell us that we're correct. And so that's something that we have to keep in mind, are double bonds and lone pairs and the effects that those have on changing the ideal bond angle. And you should be able to know how to handle those.